Welcome to Mathematics with Afzal. Today we are going to learn 10th standard first chapter real numbers chapter. In board exam, four different type of questions will be asking in this chapter. The first one is fundamental theorem of arithmetic. Second one, express as product of primes. Third one, HCF and LCM by using prime factorization method and verify the relation. Fourth one, prove that irrational number. Before going to the real numbers chapter, first we should know the some type of numbers, that is even numbers. The numbers which are divisible by 2 are called even numbers. They are 2, 4, 6, 8, 10, 12 and so on. Odd numbers. The numbers which are not divisible by 2 are called odd numbers. That is 1, 3, 5, 7, 9, 11, 13 and so on. They are odd numbers. Next, prime numbers. The numbers which are not divisible by any number except 1 and itself. They are 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. Next, composite numbers. The numbers which has 2 or more factors except 1, it is not a prime number. They are 4, 6, 8, 10, 12, 14, 15, 16, 18, 20, 21, 22 and so on. One is neither prime number nor composite number. Co-primes. Two numbers do not have any common factor other than 1. That is, HCF of two numbers is 1. It is called co-primes. They are 2, 3, 2, 5, 2, 9, 3, 5, 3, 8 and so on. Next, one mark very important statement, fundamental theorem of arithmetic. Every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factor occurs. Show that 7 into 11 into 13 plus 13 is a composite number. First three numbers is the one term, 13 is the other term. In the 13 common if you take, remaining 7 into 11 plus 13 ones are 13. Then 13 into 7 into 11 is 77 plus 1. Then 13 into 77 plus 1, 78. 78 if you factorize, 2 39 times, 3 13 times. 13 into 78 can be written as 2 into 3 into 13. 2 into 3 into 13 2 times is there, 13 square. It has 3 factors. 2, 3, 13. Therefore, it is a composite number. According to fundamental theorem of arithmetic, 40 equals to x power y into z. Find the values of x, y and z. 40 can be factorized to 20 times, to 10 times, to 5 times. 40 equals to 2 3 times into 5. We compare those two, x value is 2, y value is 3, z value is 5. Comparison, x is 2 and y is 3, z is 5. Next question. Express as product of its primes, 96. 96 is even number. We can divide by 2 tables. 248 times, 224 times, 212 times, 26 times, 23 times. 96 can be written as 2, 1, 2, 3, 4, 5 times is there. 2 power 5 into 3. Next, 120. 120 also even number. You can divide by 2 tables, 260 times, 230 times, 215 times. 15 is the odd number, 5 times 15. 120 equal to 2 3 times is there, 2 power 3 into 3 into 5. Next, 210. 210 is even number. 2 ones are 2, 2 5s are 10. So many students will do the mistake here only. 2 15s are is 30, not 210. Here we have to take 2 next number 1 also 21. 2 10s are 20. Then remainder 1 10 2 5s are 10. Next 3 35 times. Next 5 7 times. 210 equals to 2 into 3 into 5 into 7. Next 5005. 5005 is the odd number. We can divide by 5 tables first. 5 ones are 0 0 5 ones are. Next we can do by 7 tables. 7 ones are 7. Remainder 3 30. 7 fours are 28. Remainder 2 21. 7 threes are 21. Then 11 tables. 11 ones are 11. Remainder 3 33. 11 threes are 33. And 5005 can be written as 5 into 7 into 11 into 13. Next, HCF and LCM by prime factorization method. HCF of co-primes 1. LCM of co-primes, their product. HCF of two prime numbers 1. LCM of two prime numbers, their product. HCF of even prime number and least composite number. Even prime number is 2 and least composite number is 4. That is HCF of 2 and 4. HCF of 2 and 4 is 2. Next, find the HCF of 5 power 2 into 2 and one more 2 power 5 into 5. We need to find out HCF. HCF means highest common factor, but here powers are there. If they are given the powers in the question 2 and 2 power 5, in that which is the least power 2, the one more 5 and 5 square are the powers, in that least one 5, 2 into 5. HCF is 2 5s are 10. Next question, find HCF and LCM of 6, 72 and 120 using prime factorization method. 6 factorize 2 3s are 72 factorize 2 36 times, 2 18 times, 2 9 times, 3 3 times. 120 if you factorize 2 60 times, 2 30 times, 2 15 times, 3 5 times. Now 6 can be written as 2 into 3. 72 can be written as 2 3 times and 3 2 times. 120 can be written as 2 3 times into 3 into 5. First HCF. HCF means which number is common in all 3 places. 2 and 3. 2 into 3. HCF is 2 3s are 6. Next LCM. LCM means first write HCF 2 into 3 and which is not common, that also I have to mention. That is, here again 2 times is there, will take only 1 time. Here again 2 times is there, here also will take 2 1 time. So 3 and 5 1 time is there, take 1 and 5 also 1 time. So multiply everything. 2 3s are 6, 6 2s are 12, 12 2s are 24, 24 3s are 72, 72 into 5, 360. LCM is 360. Next question. Find HCF of 135 and 75 by prime factorization method, and then find the LCM of 20 and HCF of 135 and 75. First we'll find out HCF of 135 and 75. 135 is an odd number. First we can divide by 3 tables. 3 4s are 12, remainder 1, 3 5s are 15. Then 3 15 times 45. Then 3 5 times 15. Next 75. 75 also odd number, we can divide by 3 tables. 3 2s are 6, remainder 1, 3 5s are, and 5 5s are 25. So 135 can be written as 3 times into 5. 75 can be written as 3 into 5 into 5. First, we'll find out the HCF. HCF is which number is common in both 3 and 5. 3 into 5. HCF is 50. Now again one more question they are asking in the LCM of 20 and HCF of 135 and 75 equal to, that is 20 comma HCF of 135 and 75 is just now we found 15. That means LCM of 20 comma 15 we have to find out. 20 if you factorize 2 10 times, 2 5 times. 15 if you factorize 3 5 times. That is 20 equals to 2 into 2 into 5. 15 equals to 3 into 5. Then HCF. HCF means which is common 5. But we need here LCM. LCM means which is common and which is not common also I have to write. 2 into 2 into 3. That is 5 2s are 10 and 2s are 20. 23s are 60. Therefore LCM is 60. Next question. Find the maximum length of rod completely to measure the rods of length 24 and 36 meter. Maximum length means we have to find out HCF of given number. Maximum length equal to HCF of 24 comma 36. 24 factorize to 12 times, to 6 times, to 3 times. 36 factorize to 18 times, to 9 times, 3 times. Now 24 can be written as 2 into 2 into 2 into 3. 36 can be written as 2 into 2 into 3 into 3. HCF. HCF means which is common. 2 times common and 3 1 time common. 2 into 2 into 3. 2 are 4, 4 3s are 12. Therefore maximum length of the rod is 12 meter. Next question. Find the largest number which divides 438 and 606 without leaving any remainder. Largest number equals to HCF of 438 comma 606 we have to find. 438 factorize. 2 2s are 2 1 2 9s are 3 7 3 3s are. Then 606 2 3s are 0 2 3s are 3 1s are 0 3 1s are. 101 is the prime number. It is not possible to divide further. Now HCF 438 is 2 into 3 into 73. 606 equal to 2 into 3 into 101. HCF which is common in both 2 into 3 6. Therefore the largest number is 6. Next question. A teacher has 96 pens and 128 pencils. Find the maximum number of students. Maximum number of students equals to HCF of 96 and 128. 96 if we factorize to 48 times, to 24 times, to 12 times, to 6 times, to 3 times. 120 to 64 times, to 32 times, to 16 times, 2 8 times, 2 4 times, 2 2 times. The 96 can be written as 2 5 times into 3. 128 can be written as 2 7 times. Then HCF equals to 2 how many times is common? 5 times. 2 into 2 into 2 into 2 into 2. 2 5 times if you multiply you will get 32. Therefore, maximum number of students, the pencils and the pens can be equally distributed is 32. Next question. An army contingent 616 members is to march behind an army behind of 32 members. What is the maximum number of columns? The maximum number of columns equals to HCF of 616 comma 32. 616 if you factorize 2 3 times, 0 to 8 times, 2 1, 2 5, 2 4, 2 7s are 14, again 2 7s are 14, 7 11s are 77. 32 if you factorize 2 16 times, 2 8 times, 2 4 times, 2 2 times. 616 equal to 2 multiplied by 3 times, 7 into 11. 32 can be written as 2 is multiplied by 5 times. HCF 2 3 times is common, that is 2 into 2 into 2 8. So maximum number of columns is 8. And also we have to find out number of rows in each field. Number of rows in each field equals to 32 members divided by 8, 4 rows. Next question. The lengths of two rectangular tables 84 and 126 cm respectively both have the width equal to 42 cm. Find the maximum length of square glass sheet that can be exactly fit the tables, and also calculate total number of glass sheets to fit each table. The maximum length of square glass sheet required equals to HCF of 84 comma 126. 84 can be factorized 242 times, 221 times, 3 7 times. 126 can be factorized 263 times, 321 times, 3 7 times. 84 can be written as 2 into 2 into 3 into 7. 126 can be written as 2 into 3 into 3 into 7. In that, which is common, 1 2, 1 3 and 1 7. 2 into 3 into 7. 2 3s are 6, 6 7s are 42. Therefore, the maximum length of square glass sheet required equals to 42 meters. And one more question is there. Total number of glass sheets required to fit each table. The number of glass sheets required, number of glass sheets required for table 1 equals to 84 divided by 42, 2 glass sheets. Table 2 equals to 126 divided by 42, 3 classrooms. Next question. If A and B are two positive integers, find the relation between HCF and LCM. HCF into LCM equals to product of two numbers, that is A into B is the relation. Find HCF and LCM of 26 and 91 and verify the relation. This is a very important question for 2 marks or one time they will ask for 3 marks also. 26 can be factorized 2 into 13. 91 can be factorized 7 into 13. First we need to find out HCF. HCF means which is common, 13. LCM means which is common you write and which is not common also we have to write, that is 2 into 7. 13 2s are 26. 26 into 7 if you multiply will get 182. Then we have to find out the relation. Relation is HCF into LCM equals to product of two numbers small a and small b. Small a is 26, small b is 21. HCF 13 into LCM 182 equals to small a is 26 into 91. If you multiply 13 into 182, you will be getting 2366. Same if you multiply 26 and 91 also, you will get 2366. Both are same, therefore it's verified. Next question. The HCF of 306 and 657 is 9. Find the LCM. Here we will use the relation HCF into LCM equals to A into B. We need to find out LCM equals to A into B divided by HCF. A is 306, B is 657, HCF is 9. 306 into 657 divided by 9. We cancel 9 ones are 9 sevens are 63, remainder 2, 9 threes are 21. 306 into 73 if you multiply, we will be getting the answer 22,338. The product of LCM and LCM of two numbers is 2366 and HCF is 13. Find their LCM. LCM into HCF equals to product of two numbers A and 2 B. They are given here product A into B is 2366. HCF is 13. LCM you should find out. Then LCM into HCF is 13 equal to product is 2366. LCM equals to 2366 divided by 13. If you cancel 13 and 2366, you will be getting 182. Therefore, LCM is 182. Here other question is that one number is 91. That is one number A equals to 91. Other number B equal to we have to find out. Here use again same relation, that is HCF into LCM equals to product, that is A into B. HCF value is 13, LCM is 132. One number A is 91 into B. Then B equals to 13 into 182 divided by 91. 19 ones are 19 twos are, therefore other number B is 13 twos are 26. Next question. HCF and LCM of two numbers are 4 and 60. One integer is 20. Find the other integer. HCF is 4. LCM is 60. One integer A is 20. another integer b equal to question mark. Here the relation between HCF and LCM is HCF into LCM equals to a into b. HCF is 4, LCM is 60, one number a is 20, other number b we have to find out. 4 into 60 divided by 20 equals to b. 21s are 23s are. B equals to 4 3s are 12. Therefore, other integer is 12. Next, prove that root pi is an irrational number. This is a very important question. 3 marks. Question is root 5 is there. They will be asked for root 3 also and root 2 also. For all 3 questions, pattern is same. Just change in place of root 5 either root 3 or root 2. Let us assume root 5 is an rational number. Root 5 is equal to a by b, where a and b are co-primes. Square on both sides. Square and root cancel. A square divided by b square will be. By cross multiplication, 5 into b square equal to a square. Therefore, 5 divides a square. 5 divides a. Next, let a equal to 5k, where k is an integer. Square on both sides. A square equal to 5 5s are 25 a square. But a square value is here 5b square. If you write here in place of a square 5b square equals to 25k square. If you cancel 5 1s are 5 5s are, then you will be getting b square is equal to 5k square. This one. Therefore, 5 divides b square, 5 divides b. From equation 1 and equation 2, 5 divides both a and b. Therefore, 5 is a common factor of both a and b. But a and b does not have any common factor other than 1 because they are co-primes. This contradicts our assumption is wrong. Therefore, root 5 is an irrational number. This is a very important one for 3 marks. Next type of proving irrational number. This they will ask for 2 marks. Prove that 3 plus 2 root 5 is irrational number. Let us assume 3 plus 2 root 5 is rational. 3 plus 2 root 5 equal to p by q. 2 root 5 equal to plus 3. If you transpose this side, it becomes minus 3. Then if you take the LCM, p minus 3q by q. If you 2 if you transpose, it will come down. Then it becomes p minus 3q by 2q. Since root 5 is rational, p minus 3q by 2q also rational. But root 5 is an irrational. This contradicts our assumption is wrong. Therefore, 3 plus 2 root 5 is an irrational number. This is for 2 marks question. Next, prove that 2 plus root 3 is an irrational number. Let us assume 2 plus root 3 is rational. Therefore, 2 plus root 3 equal to p by q, where p and q are co-primes. Root 3 equals to p by q. 2 if you transpose that side, it becomes minus 2. Then root 3 equal to, if you take the LCM, one denominator is there, q as it is. Then p minus 2 into q to q. Since root 3 is rational, p minus 2q divided by q is also rational. But root 3 is an irrational. This contradicts our assumption is wrong. Therefore, 2 plus root 3 is an irrational number. Show that 5 minus root 3 is irrational. Let us assume 5 minus root 3 is a rational number. Then 5 minus root 3 equals to p by q minus root 3 equals to p by q. 5 if you transpose that side, it becomes minus 5. Then minus root 3 equals to p minus, if you take the LCM, 5 into q, 5q divided by 2. Here root 3 having negative symbol. If you make it positive, root 3 equal to other expression, it becomes 5q minus p by q. Since root 3 is rational, 5q minus p divided by q also rational. But root 3 is an irrational. This contradicts our assumption is wrong. Therefore, 5 minus root 3 is an irrational number. Next 2 questions are there. Same format we have to follow, just the mathematical part I will explain. That is 3 root 2 equals to p by q. Root 2 equals to p divided by 3. If you transpose other side, it becomes 3q. Next, 1 by root 2 equals to p by q. If you make it reciprocal, root 2 equals to q by p. Today we learned real number chapter totally. For board exam, what questions will come? Everything. That is fundamental theorem of arithmetic, product of primes, and HCF, LCM and its relation, and prove that irrational number. Thank you.